right, this is section 12.5, graphing logs. And we're also going to be going into tomorrow's notes for the inverse. Tonight's homework is chapter 12, page 730. You're going to do numbers 13 through 24. And then I need you to do 25 through 36, which is on the inverses. Alright, so just like we found an inverse of any function, there are the same exact steps that you did when you solve, you're going to be using for graphing or solving for a log, the inverse of a log. So let me write out the directions for you step by step so that you have them again. Anytime you find an inverse, step 1 is to switch your x and your y. And then specifically for finding the inverse of a log, we talked about yesterday piggybacking off. So you want to remember to chop off the log and use the circle cycle. And I'll go over what that means in a minute. Step 2 is solve for y. So if I wanted to do the simplest of examples, example 1, let's say I have f of x is equal to the log base 3 of x. I'm gonna chop off the log, take out your highlighter and make sure that you do that. So remember, you're going to put a y instead of f of x. That's what you're going to first do. Then you're going to switch your x and your y, so you have x equals log base 3 of y. And then you're going to chop off the log and do the circle cycle. Or yesterday we called it the piggybacking. So this piggybacks the x equaling the y. The purpose of a log is to solve for the exponent. Say that with me. The purpose of a log is to? The purpose of a log is to? So anytime you have a log, you know you've solved for the exponent. That's why there's a log there. So you're going to chop off the log. And then you're going to do the circle cycle. So then that means the 3 piggybacks the x equaling the y. So this is the inverse of f of x equaling log base 3 of x. These guys are inverses. Questions on example 1? Now the way we signify an inverse is you put a little -1 up here. That's how you tell people that's the inverse. You don't really say y of -1 or f of -1, you just say y inverse. Yes, we have. If it would be what, honey? Here? If this says x squared, yeah, it would be 3 to the x squared. Whatever this is, baby girl, that's the exponent.
And then for the y, where it's equal to y, would it be y to the second? Or would it still be y to the first?
It would just be whatever this argument is. Good question. So let's do a couple more, babe. I think you'll feel better after we do a couple more. Example 2. Let's say we want to find the inverse of y equals log base 2 of x minus 3. Well, step 1 is to switch x and y. So that's what I'm going to do. So that's x equals log base 2 of y minus 3. We want to make sure that we isolate the log. So our step 2 is going to be to isolate the log. Because you can't do the piggyback if there's this 3 hanging out here. You got to move them over first. So we're isolating the log. That means I'm going to put this minus 3 on the other side. God bless you. So that's x plus 3 equals log base 2 of y. Step 3, we're going to cancel the log. And circle it up. So I had an x plus 3 log base 2 of y. I'm going to cancel the log. And cycle. When I do the cycle, I get 2 to the x plus 3. 2 to the x plus 3 equals y. My final answer is y inverse is equal to the x plus 3. And to be safe, I'm just going to put that in parentheses. What do you guys think? Pretty okay? Should I do one more, or do you guys want to try one? Alright, here's your dial. Find the inverse. Y equals log base 2 of x plus 3. This would be a 96. Just sit right here. Daisy, what did you do first, honey?
I switched the x and y.
Okay, please tell me what to write.
So it's going to be x equals log base of 2, and this is y plus
Okay, perfect.
2.
I know what you meant. So far, so good? Mina, what'd you do next?
Take out the log.
Mm-hmm. You canceled the logs and then did the... So once you cancel the... What do we call that?
And use the circle.
Use the circle cycle, right? So you want to cancel the log and then do the circle cycle, or some of you guys might remember as a piggyback, you're just going to piggyback off the other one. How come I don't have to take anything outside of here though? How come I don't have to move the plus 3 over? I don't get it. Isn't that what I had to do last time? How come I don't subtract 3 on both sides? It's inside the argument. So the log is now isolated. It's done. If it was outside of the argument, then you got to move it over and get rid of it. It's inside the argument. It's part of the log. How are you going to take it out? It's part of the log. So you can't subtract 3 on both sides. It's not outside of the log. It's inside the argument of the log. And that's why I wanted to do this problem with you, so you could see the difference. Okay? So the log is isolated. It's already, it's isolated already. So now you just log it up. Cancel the log and do the circle cycle. So now you just get rid of the log. Piggyback, make it equal to that.
So 2 to the power of 2x
2 to the
x
equals
y plus 3.
y plus 3. But we're not done yet because you have to solve for what letter? Y. So y equals 2 to the x minus 3. Now how do you write this? Don't forget to tell people this is the inverse. So the inverse is 2 to the x minus 3. Sometimes we have to go in the opposite direction, no problem. Example 3. If I have y equals 5 to the x plus 3, I do the same thing. Switch my x and my y. I want to get rid of this 3 right here so that I can do my log and introduce the log this time. So now I have x minus 3 equals 5 to the y. The purpose of a log is to solve for the exponent. What's the exponent here? Which one of these is the exponent? Y. So you know the y is over here. Who piggybacked the y? The 5. That means the 5 was here. Who did I lose there? So doesn't this say 5 to the y? The purpose of a log is to solve for the exponent. So you know this is the exponent. Y. Well, who piggybacked the y? Wasn't it the 5? So before it would be like, boop, the 5 piggybacked the y. And then what did it equal? What does it equal over here? What does it say right here? X minus 3. Well, what do I need to insert right here? Because before you canceled it, so now you need to input that. And now just double check it so that you're sure. If you were to cancel the log and do the circle cycle, do you get back to this? Yes, 5 to the y equals x minus 3. I'm not quite done yet because I have to tell people it's the inverse. So y inverse is log base 5 of x minus 3. Sorry. I want to do one more and then we'll do an example together. Example 4, and then you guys will do a doyo. You guys, you're in the video. All of this is in the video. All right. Let's find the inverse of y equals 7 to the x minus 2. My first step is to switch my x and y. I can't log it up yet until I gotta get the 7 to the y by itself. So what do I have to move over? 2. So what am I gonna put? X plus 2 equals 7 to the y. How do I solve for y here? The purpose of the log is to solve for the exponent. If you have a 7 to the y, you can't square root it, you can't 7th root it. There's a y in the exponent. Your only choice is to log it up. Everybody with me? So you have no choice but to log it up. So now, the purpose of the log is to solve for the exponent. So you know the exponent was y. You're going to log it up. What was down there was a 7. And what does that equal? X plus 2. Tell people it's the inverse. Don't forget to put that y inverse. Alright, here's your doyo. Let's see if you recognize the difference. Please find the inverse. You guys know what I'm going to do already. Y equals to 7 to the x minus 2. How is that different? Ashley, what shall I do first? So x equals 7 to the y minus 2. Oshini, now what? Wait, so what do you do from here? Are you allowed to log it up from here? The purpose of a log is to solve for the exponent. Isn't what I'm trying to do solve for the exponent? Do I have anything out here that I need to get rid of first? So what's my only choice if I need to solve for the exponent? I gotta log it up. So what do I write? Oshini, go ahead. Log 7 or log base 7? Okay. Log base 7. Uh-huh. What does this equal? Equals. So is the exponent y? That's it? That's what the exponent is? Sorry. The purpose of a log is to solve for the what? What's the exponent here? Just 2? Thank you. What is the exponent again? Thank you. Alright, example 5 is going to help you with tonight's homework. They're going to give us some characteristics about our functions, and then we have to transform the function. So example 5, let's say that they have f of x is equal to the log base 2 of x with the following characteristics. Let's say that it has a vertical asymptote at x equaling 4. We know from yesterday what a function looks like if it has a vertical asymptote at x equaling 4. So if you take a look at yesterday's notes, if I'm flipping, you should be flipping. For example, example 3 yesterday, I had an asymptote at x equaling 5. That means the domain was 5 to infinity because the actual argument was changed. When the actual argument is changed, you have an asymptote there. So in this example 5, they want you to create a new function called c of x that has an asymptote at x equaling 4. That's going to be f of x minus 4. Now, why isn't it x plus 4? Because remember, you're going to set this equal to 0. And when you set this equal to 0, x minus 4 equaling 0, you get x equals 4, not negative 4. Example 6, what if they tell me that they want this function again? And they want me to create a function c of x where the domain is negative infinity to 2. So the 2 has a role, and so does that negative infinity. Yesterday I had an example where my domain was on the negative side because it got reflected. You guys remember that? So these had a domain of -1 to infinity. Here I had 5 to infinity, 0 to infinity. But then, oh, I didn't do it with you guys, it was the other class. But then if I was on the other side, it's because it got flipped to the y-axis or the x-axis. If my graph exists from negative infinity to 2, that means my graph is on this side somewhere. That means it got flipped either across the x or across the y. The original graph of the log, doesn't it go right here? Like this? How the heck did it go over here? Did it get flipped across the x or across the y? Across the y. If you flip across the y, do you negate the function or negate the argument? You negate the argument. Nicely done. So the answer to this would be c of x is equal to f, negate the argument, and then since there's a 2 right there, plus 2. Who's your doyo? What if the characteristic had a vertical asymptote at x equaling -2? Write the function for me, please. Yeah. Oh, because remember this deals with the range, remember? Oh, I know what you're asking, Jessica. You're used to seeing it like this. F of, so you'll have like c of x is equal to f of x, and then you're used to seeing that function, and then -2, right? But you have to negate the entire argument, so it becomes this. I know, it's a lot. Did you guys get this one? If the vertical asymptote is that x equals -2, what do you get? C of x is equal to what? F of? The vertical asymptote has to be -2, so is it going to be x minus 2 or x plus 2? X plus 2. Alright. We do need to keep going, guys. Sorry, there's a lot. Example 7. I want us to look at number 29 together on the homework, and that's going to be in our example 7. Okay, if we read the directions, consider the function f of x 4 to the x and its inverse log base 4 of x. So now we already know how to do from here to here. You guys already know how to do this. Now we're going to complete the table for each transformation and write the transformation function in terms of its inverse. Then we're going to identify what that transformation is. So the original function is f of x equals 4 to the x, and then that's the inverse of it is log base 4 of x. So let's write that down. We have f of x is equal to 4 to the x, and then we have its inverse, which we already know how to find now, as being turn that off here, please, before this runs. Log base 4 of x. Here. That's scary.
The volume for that is number 25.
But it's the same directions for 25, 26, 27, 28, 29. All right, so here's the table for number 29. I really need you guys to make sure you have the same numbers I have. Can I see your thing? I don't want to write the wrong numbers. Okay, perfect. So they gave me h of x is now different 12 times f of x. F of x is right here. That's why I needed this f of x. It's 12 times that. And then they are telling me to find its inverse. Well, its inverse is going to be the opposite operation of being multiplied. So its inverse is going to be the inverse of f, and instead of multiplying by 5, I'm going to divide by 12. Instead of multiplying by 12, I'm going to divide by 12. So literally everything here is opposite. I need you to be convinced of that. H inverse. Times 12 divided by 12. Instead of an F, it's F inverse. All right. What happens if I plug in -1 into this function here? Ready? What's 4 to the -1? 1/4. What's 1/4 of 12? 3. And what do you know about inverses? Let's go back to last chapter. What do you know about inverses? This should be what? 3 -1. So what I'm going to do is I'm going to find 3 points here, and then I'm going to switch them on this side so I can graph the inverse. What happens if I plug in 0 here? What's 4 to the 0? 1. What's 1 times 12? 12. So the inverse is going to be what? 12, 0. And if I plug in 1, what's 4 to the 1? 4. 4 times 12? 48. So its inverse is going to be 48, 1. Now, I just need to remind you of some terminology. Remember, when we multiply by 12, we're now dilating. We're making we're either compressing something or dilating something. So when we multiply by 12, they're going to ask me, what is the transformation? And I just need to remind you on some vocabulary. This transformation would be called a vertical dilation of 12. That's this. Vertical dilation of 12. Sorry. Vertical dilation of 12 is this right here. This goes with this. Then they ask me, what about the inverse? And what's the opposite of a vertical dilation? horizontal dilation of 12. So this, in yellow, is this part. So this is the actual function, and this is the inverse. Look at number 30. And make that your doyo. Go ahead and do number 30 now. It's part of tomorrow's homework anyway, but do number 30 right now. Make that your doyo. And then I'll show you the answer to make sure that you're getting it right. All right. So from yesterday's notes, I need you to make sure that everybody in your group knows when it's reflected across the X and reflected across the Y and what it looks like. 15 seconds in your group. Make sure everybody's okay with that. Go.
If it reflects across the
All right, let's go over some answers from the homework so we can get through our notes. I apologize ahead of time since I'm going through 2 sets of notes. It's gonna feel a little fast, but if you're totally focusing on it, you should be fine, okay? But if you just like doze off for a little 10 seconds that sometimes you guys do, you're gonna come back and it'll be a hot mess. So I just need you to focus and get through this with me. Last night's homework, I wanted to show you guys some of the answers that you should have gotten. So if you take a look at number 3, you would have noticed that that change, was this last night or the night before? Yeah, this was last night's. You would have noticed that this change, you moved to the left 2, and what does this minus 5 mean? Down 5. So I'm just gonna show you the answers to make sure that you're getting them right. This should have been an x plus 2 and a minus 5. Does everybody know where I got that log base 4 from? It's right there. It's from the original equation, okay? So I'm going to zoom in so that you can check your answers. Number 4, you should have had a compression, or stretch, sorry, of 6, because it didn't move left and right. It just got fatter or skinnier. It just got stretched. So there should have been a 6 right there. Is this the one we did? Or did we do number 6? Number 5, it got flipped across the x-axis and it got moved to the right. This is the one we did.
Yeah.
And then number 6, this time we got flipped over the x-axis and then it moved up 3 units. At the very least, I want you to write these down because it is your responsibility to get these questions answered before the day of the test. The best time to do that is to come after school in hour power and get the help that you need. Survey, question. Mostly right or mostly wrong? Okay. All right. Next thing I want to do is make sure that we're okay on tonight's homework. So while we take our notes, please make sure that today's homework is on your phone, ready to go, so that when I ask you to find a question, it's already there. I don't want you wasting time looking for it when I ask you to find it. Are there any questions on last night's homework 7 through 12? Yes, sir? Number 10, sure. Number 10 is a little different because a lot of you guys forgot that you have to set the argument equal to 0. You don't just put 3 or 2. You have to say 2x minus 3 equals 0. So 2x equals 3. That means x is equal to 3 halves. That's your asymptote. Since your asymptote is x equals 3 halves, then you know your domain is 3 halves to infinity, and your range is always negative infinity to infinity. Miss Riad, I thought you just make it the opposite. Yeah, you make it the opposite because that's what makes the argument 0. When you put x plus 1 equals 0, you get x equals negative 1. That's why it's the opposite, because it's what makes it 0. So that's why this has to be a 3 halves.